Okay, welcome back, and we come up to the last section, probably the most important section, safety first. Let's begin. Okay, last section, safety first. Okay, good way to guard against electrical shock at your station. Use 3-wire cords and plugs for all AC-powered equipment. Connect AC-powered station equipment to a common safety ground. Use a circuit protection by ground fault interrupter, GFCI. All these choices are correct. So here's your GFCI receptacle. You've all seen that. You got a test button, a reset button. And the way this works is that it compares the power of the hot lead versus the cold lead. So power in has to equal power out. If there's an imbalance, there's something wrong and it trips it. And that's basically how the GFCI works. GFCIs you want to use at any wet location, outdoor location, crawl space, unfinished basements, that sort of thing. They're not that expensive either. So the green wire in a 3-wire electrical AC plug is safety ground. So you'll have a green wire, a white wire, and a black wire. The green wire is ground. A fuse or a circuit breaker in series with the AC hot conductor should always be included with home-built equipment that's powered by 120 volts. So you always need a circuit breaker or a fuse on your hot lead coming into any of your equipment if it's AC powered. The purpose of a fuse in an electrical circuit is to interrupt power in case there's an overload. And please don't bypass fuses. There's people have bypassed the fuses with 22 caliber bullets. People have done tinfoil around the fuse. Please don't do that. Use the appropriate fuse with the appropriate rating. Good way to guard against electrical shock in your station. Use 3-wire cords and plugs for all AC powered equipment. Oh, we already went over that. Sorry. There we go. Okay, here we go. It's unwise to install a 20 amp fuse in place of a 5 amp fuse, as excessive current could cause a fire. So again, use the appropriate rating fuse for your load. If it requires a 5 amp, put a 5 amp in. If it requires a 10 amp, put a 10 amp in. Don't go over, because you can actually cause a fire. Hazard might exist in a power supply when it's turned off and disconnected from a charge stored in a large capacitor that can give you a shock. So in a lot of big linear supplies, we have very large capacitors. They should be a bleeder resistor across it, but that's not always the case. So you just want to be careful poking your fingers in there that you can have a charged capacitor, because it stays charged for a long time. When measuring high voltages with a voltmeter, ensure that the voltmeter leads are rated for the use of the voltage being measured. Alright, this goes back to a few slides back. I was talking about category ratings on meters. Typically, they're around either 300 or 600 volts and at different categories. Just want to make sure if they're measuring anything high voltage that you got the correct leads, because it might shock you through the insulation if you don't. Current flowing through the body can cause health hazards by heating the tissue, by disrupting electrical functions of the cells, by causing involuntary muscle contractions. All these choices are correct. If commercial power is out, recharge a 12-volt lead-acid station battery by connecting the battery in parallel with the vehicle battery and run the engine. So if you lose your power, your ham radio equipment usually will operate on 12 volts DC, and if you have a spare battery laying around, you can use that. And to charge that, all you have to do is connect a set of jumping cables and connect it across your battery in your car, and you can start up the car and charge your secondary battery. Very common thing to do. If a lead-acid storage battery is charged or discharged too fast, it could overheat and give off flammable gas and explode. Okay, so when you charge or discharge it very fast, it produces hydrogen. And hydrogen is explosive. So again, you want to charge your batteries in a ventilated area. If you have a failure in your charger and start charging too quick, it'll vent off hydrogen gas. A safety hazard for 12-volt storage batteries: if the terminals are shorted, could cause burn, fires, or explosion. So you got to be real careful when working around these batteries, and you don't want to accidentally touch the two terminals together with a wrench or something metal, because it could cause hundreds of amps to flow through it, and it gets really hot and it could cause a burn, a fire, explosion, or all three. Okay, so here is a battery, and someone accidentally got shorted. Looks like across their ring finger with the ring, and actually burnt them. And actually, my instructor did this when I was in the Votech years ago. He actually had the gold melt on his finger, and they had to come over and with a pair of bolt cutters and cut it off his finger. And he was deformed for that for a very, very long time. So be careful with jewelry, right? If you're poking around high current circuits, high voltage and high current circuits. A conventional 12-volt battery can collect explosive gas if not properly ventilated. So if you have a set of batteries, lead-acid batteries, just make sure you charge them either in a well-ventilated area or outside. When putting up an antenna tower, make sure you look for and stay clear of any overhead electrical wires. So whenever you're putting up antennas of any type, not even just a tower, you want to make sure and stay clear of overhead electrical lines. Same thing with ladders too. When installing an antenna, if it falls, make sure no part can come closer than 10 feet to the power lines. So you want to be at 10 feet away from any type of power lines if it falls down. Your antenna could contact the high voltage power lines if attached to a utility pole. So we don't want to put antennas on a utility pole that is owned by the electric company. Up in the high ends, down on my street, we have 14,400 volts on the top line. You don't want to be messing with any of that stuff. So don't put your antennas on utility poles, and it is illegal too. Wear safety goggles and climbing harness before climbing an antenna tower. We have hams die every year for this. They have a harness on. They don't have their harness on, they fall off a tower. It happens a lot, so please use a climbing harness, safety glasses, and a hard hat. All your safety equipment. We don't want any hams dying off of the antennas because they didn't do this. It's never safe to climb a tower without a helper or observer. Right. At all times when any work is being done in a tower, all members should wear a hard hat. That's in case something falls. You don't want anything banging on your head. Okay, a gin pole is used to lift tower sections or antennas. So here is a typical use of a gin pole, and it's slightly above where you're placing the next section of the tower, and that's your typical setup. Okay. When using a crank-up tower, never climb the tower unless it is fully retracted. So you don't want to, if you have a crank-up tower, make sure it's fully retracted before climbing on it. Local electrical codes establishing ground requirements for amateur tower or radio. So you want to make sure you look at your local codes for grounding if you're putting up an antenna or a tower. So a proper grounding for a tower is accomplished by using separate 8-foot long ground rods for each tower leg, bonded to the tower and each other. So what I mean by bonded, something mechanically holding on to the leg and to the ground. You don't want to solder, right? If you solder this, when a lightning bolt comes and hits it, it's just going to melt the solder and open up. You want a good, strong mechanical and electrical connection at the tower leg. Flat strap of conductor is best used for RF grounding. Again, with that that skin effect I was talking to you about earlier in the coax. Same thing with grounds. Good ground would be a good strap type conductor for a good RF ground. Good practice when installing ground wires on a tower for lightning protection is to ensure that the connections are short and direct. Avoid sharp bends on the grounding conductors used for lightning protection. When installing devices for lightning protection and coax cable, feed line ground all the protectors to a common plate, which in turn connects to an external ground. Factors affecting RF exposure of people near an amateur station antenna. So There's charts that you can use to make sure that you're not exposing anyone to hazardous RF radiation. So you want to make sure you got the frequency and power level, distance from the antenna to the person, the radiation pattern of the antenna. All these choices are correct. So there's charts online that you can look up for exposure limits. Exposure limits will vary depending on frequency because human body absorbs more RF energy at some frequencies than at others. Right around 50 megahertz is the frequency that has the lowest value for maximum permanent exposure limit. The maximum power level that an amateur radio station may use at VHF frequencies before RF exposure evaluation is required is 50 watts PEP at the antenna. VHF and UHF radio signals are non-ionizing type of radiation. Acceptable methods to determine that your station complies with FCC RF exposure regulations. You want to, by calculations by the FCC OET Bulletin 65, by calculations based on computer modeling, by the measurement of a field strength using calibrated equipment. All these choices are correct. Relocate an antenna to prevent exposure to RF radiation in excess of the FCC's supplemented limits. Reevaluate your station whenever an item of equipment is changed to stay compliant with RF safety regulations. Duty cycle during the average time for RF exposure is the percentage of time that a transmitter is transmitting. RF radiation differs from ionization radiation, radioactivity, in that RF radiation does not have sufficient energy to cause genetic damage. If the averaging time for the exposure is 6 minutes, there is 2 times as much exposure when transmitting for an entire 6 minutes versus transmitting for 3 minutes and absent for 3 minutes. That's the duty cycle that I was talking about earlier. Duty cycle is one factor used to determine the safe RF radiation exposure limits because its effect on the average exposure of people to radiation. Okay, one might receive a painful RF burn if they accidentally touch an antenna while it's transmitting. I've had this happen across a connector, and it is very painful, these burns. Alright, so we're going to go on to the Q&A section on safety on the next set. See you then.